Hello there, 2D'ers. We're back again with another video. Supervising teacher, I'd like, if you could please, to pause the video, give the kids a chance to try the 3-minute review, and again, take a couple more minutes than 3 minutes, probably about 5 minutes, maybe 10 minutes at the very most, to try these two questions, and then I'll take them up once everyone's had their chance. And go through it, try and go through it fairly quickly. So if you could pause the video now. All right, here we go, taking it up. By substitution, the idea is we've got an expression that's equal to y, so I'm going to take out the y. Take out the y and put in what y is equal to. Looks something like this. Plus 1 equals 0. So in this one, I took out the y and put in the negative 2x plus 1 and remove brackets. Select like terms. Select terms there. Negative x plus 4 equals 0. X goes to the other side. X equals 4. Sub back into 1. Or 2, it doesn't matter. I'm going to use that one. I think that's easier. And that works out to negative 8 plus 1 is negative 7. Dandy. So therefore the solution is 4, negative 7. And then the second one is to solve a given system by elimination. And notice that I could eliminate either one of these variables, but I see from the first one that all I would have to do is multiply this first one by negative 3, and then the y coordinates, coefficients rather, would line up, and I could add and eliminate the y. So I'm going to go negative 3 times 1, write that new equation down. And then I'm just going to copy equation 2 underneath. And remember, I really like to have a positive and negative here so I can just add down. The book will subtract at times, and you're welcome to subtract, but this is a way that I can avoid goofing up my negatives. Divide by negative 1 and I get x equals 4. Sub into one of them, it doesn't matter which one. And remember, after I get through all this, that I could, if I wanted to, do a formal check, left side equals right side, in the other one, not the one that I used to substitute to get to the y value, but into the other one, and I get negative 7. I get actually the same solution, and I don't know if you noticed that, but it's actually the same system, right? The exact same system. If I were to put the negative 2x to the other side, it would be the same as 1. I put the 1 over the other side. They're actually the same system, but the question is, and this is completely opinion, this is letting you sort of reflect on what your own math preferences are, is which did you like better? Do you like substitution better or elimination better? And it just doesn't matter which. Okay, good. So hopefully you got that. And of course, I need a closing sentence there. I'll let you do a better job than me, but on to the lesson now. You should have a handout with all this stuff on. So again, we've got 3 systems that we're going to take care of, and today we call elimination day 2, but really what this is spring training. Spring training for equations is what it is. See, these are a mess. They're out of shape equations, huffing and wheezing from a long winter, and they need to be whipped into shape. So the idea is we're going to change these so they look more like what we're used to for elimination. So for instance, this one's got x's and y's on opposite side, but not y equals mx plus b. So, geez, let's fix it up, right? What I'm going to do is whip that one into shape. Just put the 2y on the other side. Moving that over the other side becomes this, and that looks pretty good. I could multiply both sides by negative 1, but I'm going to call that my equation 3. This one, not much spring training needs. It was only a little bit out of shape. This second one, though, is way out of shape, right? It doesn't look like a line at all. It looks like a mess. So we have to do some serious wind sprints on this one. We need to whip this one into shape. And what do we need to do? We need to remove the brackets, multiply through and remove the brackets, collect some like terms there. And that's 8 equals negative 10. Even this isn't perfect. I'm going to move the 8 over to the other side here and get negative 18. See, that's better. That one's now in shape, ready for elimination. So, or substitution, I suppose I could choose. I'm going to put the two that I have together so I can look at these new equations now that they're ready for elimination. Well, what am I going to do? I can multiply this one by 3 and this one by 2, then the x coordinates would line up. And if you prefer to get rid of the y's, you could do that too. So I'm going to go negative 3 times equation 4. Actually, I'm not. I'm going to go positive 3 because they're already opposites, right? So I'm going to go 6x minus 9y equals, you get a little bit worried when the numbers get as big as negative 54, but again, try not to reach for your calculator. It'll just slow you down. Multiply 2 by the third equation. 2 by the third equation, and then I get negative 6x minus 4y equals 2 times 1 is 2, I believe. And then again, I'm adding down like I like to. The x's are gone just like I planned. Negative 13y equals negative 52. And as all card players know, 13 goes into 52 4 times. 4 suits in a deck, right? Deck of cards, 13 cards each, 4 suits. Easy arithmetic. And now I got to substitute back. And do I care? Am I going to go all the way back into one of these messed up, out of shape equations? Nah. As long as we didn't make a mistake, let's use one of these easier ones. Like maybe 4 looks good. So I got 2x minus 3 times 4 equals, where was it? 2x minus 3 times 4 equals negative 18. And remember, you can substitute into either of those ones. I'm a little bit worried about this. Adding 12 to both sides. Adding 12 to both sides, minus 6, x equals minus 3. And remember, I could do a formal check to make sure that works. But therefore, the solution is negative 3, 4. Or again, some of us like separating it into its 2 pieces. But it doesn't matter. All right. So what's new about this? And the new stuff is this business right here. This is sort of the spring training, right? Whipping the equations into shape. I'm going to get rid of this one for right now. Just get it out of the way. Probably not enough room on your sheet. You'll probably have to pull in another piece of paper in here. All right. So I call this equation 1 and this equation 2. Some people are okay working with decimals. Me, I think these equations are out of shape. But we need to get rid of the decimals. How do we get rid of the decimals? Is we multiply by the first one, I can multiply by 10. If I multiply by 10, the 0.3 becomes 3a, the 0.4 becomes 4b, and this part becomes negative 0.4 times 10 is negative 4. See, this is a lot nicer. This is a lot better equation. When I got 2 decimals, I'm going to multiply by 100. And again, why am I doing this? I'm doing this because I got good at the stuff yesterday, and I would like these equations, today's equations, to look like yesterday's equations. I spent so much time on. I'm just going to put the 11 on the other side so it looks just like what we're used to. And then I'm going to call this equation 3 and equation 4. And these are the 2 equations I'm going to put through my elimination, not these ones with these cruddy decimal places, okay? I think just for funsies, I'm going to eliminate b here. I see I can multiply this one by 3 and this one by 2 and have the coefficients of b be 12, this equation and this equation are the ones I'm going to work on, and eliminate the b. So I'm going to go 3 times equation 3 and negative 2 times equation 4. And again, the reason why I multiply by a negative is so I can avoid subtracting. You know, I don't want to goof up my integers. And so now the positive 12 and negative 12b's will cancel out, and I'm left with negative 5a equals 10, which is pretty nice because it works out great. Divide by negative 5, a equals negative 2. Sub back, and I get just dandy here. And again, I don't have to substitute back into the out of shape equations. I'm going to do substitute into one of the in shape equations. Add 6 to both sides, and I get b is a fraction or a decimal, and we should check that one. You always get worried about when you get a decimal or a fraction answer that's not right, but we can substitute into the other one of these ones, or even the out of shape equations, and see that in fact the answer is a equals negative 2, b equals 0.5. I check my notes, make sure that I haven't made an error. Yep, that looks good. That looks good. And now I'm going to take this last one, which looks like the nastiest, most out of shape equations. These might be the Blue Jay. These are the Blue Jay equations right here. So let me copy that. Get a whole new page for the Blue Jay equations. The Bautista. This one's a Bautista equation. Call that equation 1 and equation 2. And you probably are getting the idea here. You know, in the decimals, we multiplied something to get rid of the decimals. When I got fractions, what am I going to do? Well, I'm going to multiply by something to get rid of the fractions, kill the fractions, right? We've worked on these earlier. What will do the trick? Well, the lowest common denominator, what we're going to do is multiply by 12. Right? Multiply each thing by 12. And again, what I can do if I want to show the step there that I did, elimination style, spring training style, and notice that here 3 goes into itself once and into 12 4 times. So I'm actually not multiplying by 12. I'm multiplying by what's left over after I divide. Multiply by 4. And then here, multiplying not by 12 but by 3. And 3 times b. Get that a little thinner so it looks nicer. And nothing on the bottom here, so 8 times 12, watch your times tables. This is almost in a nice form, and now it is, right? Now it's not bad, so I'm going to call that my equation 3. And I got to whip this other one into shape too. This other one is, and again, all this stuff here is my spring training. Preseason, I guess, if you're hockey fans. So what number will kill all the fractions at once? Well, it's going to be 10. 10 because it'll kill the 5 and the 2 at the same time. And what happens here? Well, 5 goes into itself once and into 10 twice. After I do the dividing, I'm not multiplying by 10, but I'm actually multiplying by 2. And here, multiplying by, not by 10, but 2 goes into itself once and into 10 5 times. 5 times 1b. 10 times 10, nothing to divide there is 100. And then simplify this, just one more step. And this is equation 4 now. And now I'm going to use these two equations. I'm going to rewrite number 3 right below it, so it looks like I have a decent system. This looks like a normal system. And now I'm going to use these for elimination. Notice that if I multiply the first one, for the fourth equation, I guess, by -2, that the A coefficients will line up and all will be great. -8A minus 10B equals -200. You get a little bit scared like that. Is that scared? Yeah, a little bit scared about seeing the -200, that the numbers are getting too big, but I think this one's going to be okay. It'll be okay. We'll be all right. Add. Worry about the big numbers. The A's cancel out. -13B, right? Because we're adding, and that's -104. Divide by -13, and hopefully this goes evenly, and it does. That's 8. And then we could sub back into not one of the out of shape equations, but one of the nice ones, 3 or 4, doesn't matter which one, maybe 4 or 3, doesn't matter. 4 times A plus 5 times 8 is 100 plus 40 equals 100. Subtract 40 from each side. 4A equals 60. Divide by 4 and you get the answer 15. Therefore, the solution is A equals 15, B equals 8. And I should, even with the fractions, be able to go back in here and get this to work out. So if A was, what was A? A was 15 and B was 8. Do this sort of in your head on a test, right? 2 times 15 is 30, divided by 3 is 10. 8 divided by 4 is 2. Is that equal to the right-hand side 8? Yes, it is. So we're pretty happy about that, aren't we? Okay. That's it for the lesson. Hopefully you got all that. Remember, if I was going too fast, that there is a link on the website to this video, and there's some homework for you. If you get done, remember, you got lots of bonus sheets and problems of the week and all sorts of old homework to work on if you get all those done. So good luck with that, and we'll see you next time.